Hello, everyone, and welcome to our webinar on software certification. My name is Tracy Berardi, Program Director of CISQ, the Consortium for Information and Software Quality. We are partnering today with the TIC Council to talk about trends in software certification. We're really glad everybody could join us today. So to get us started, Dr. Bill Curtis, Executive Director of CISQ, will begin by introducing CISQ and the work that we do to develop software measurement standards. Then Karen Athanas, Executive Director of the TIC Council here in the States, will introduce their work. And TIC is testing, inspection, and certification. And our two main presenters today are Dr. Curtis and Matthias Haynl from TÜV and the TIC Council, talking about the state of software certification. So before we get started, I just want to mention that there is a copy of the slide deck in the Handouts tab. The video recording will be available on the CISQ website later this afternoon. And we'd like to engage in discussion with you, so feel free to enter your questions in the questions tab, and we'll get to those at the end. And we look forward to talking about next steps around software certification. So why don't I hand this over to Dr. Bill Curtis from CISQ to get started.
Thank you, Tracy. Welcome, everyone. Let me give you some real quick background on the Consortium for Information and Software Quality before we launch into today's content. CISQ was started in 2010 by Dr. Paul Nielsen, who's head of the Software Engineering Institute at Carnegie Mellon, and Dr. Richard Soley, who's head of the Object Management Group, which is an international standards organization. And they were getting requests for automating measures of software, various software qualities, because a lot of companies were seeing these in contracts, especially outsourcers and system integrators and folks like that. And there were no standards. So they would have a different definition of what reliability or security or maintainability is from each different customer. And it was very difficult to deal with. So they asked those organizations, since they both dealt with software measurement and with standards, could you come up with international standards? So we formed CISQ. Tracy, hit the next button. And our charter was to develop specifications for measures of software systems, both size and quality, that could be automated, with automation being the key, and then put those through the OMG standardization process and get them authorized as OMG standards. And OMG has a fast track to ISO. So I'll show you later what's been submitted to ISO and what they've accepted. So that's what CISQ does. It builds standards for measuring various aspects of software and the sort of the environment around software. You can see over here on the right our sponsors. We have a number of sponsors, one of which is CAS Software, where I work, and Synopsys and Tech Mahindra, 7N, and a number of others. We also have a number of partners that we cooperate with in kind of sharing information and advertising each other's conferences and what have you. So later on, we'll show you the CISQ website. Membership is free because of our sponsors sponsor the work that's being done at CISQ. And we will encourage you to go to the website and join CISQ, where you can get a lot of the standards and a lot of other information about software measurement, and it's free. So let me now turn it over to Karen.
Thank you so much, and welcome to our attendees, and thank you for joining us today. TIC Council is honored to be co-hosting this event with the Consortium for Information and Software Quality on the topic of certifying software, why, how, and next steps. TIC Council is the global trade federation representing the independent third-party testing, inspection, and certification industry, which brings together more than 90 member companies and organizations from around the world to speak with one voice. TIC Council operates in 4 major hubs, which you can see in the map that we've displayed, including our headquarters in Brussels, Belgium, our Americas branch in Washington, D.C., which is where I'm the executive director, and our operations in both Asia and India. Next slide. Through the provision of TIC services, TIC Council members assure that not only regulatory requirements are met, but also that reliability, economic value, and sustainability are enhanced through our services. Worldwide, digitalization is growing exponentially, especially now at a time when an unprecedented number of employees are logging in and working from home, using technology to support their day-to-day work. And due to this, a specialized focus and action is needed on the topic of software reliability, and a look to the future at the role that artificial intelligence will play. I'm looking forward to today's presentation, and I'm thankful to CISQ and our presenters for agreeing to share their knowledge with us on this important topic. Tracy, thank you again, and I'll hand it over to you.
Yeah, thank you, Karen. It's really our pleasure to partner with you on this. So Dr. Curtis is going to set the stage here for the need for software certification.
Thank you, Tracy. Let's go to the next slide. I mean, why do we need this? You know, we're in the era of 9-digit glitches. And when I say 9 digits, you're thinking, do you mean bits or bytes? No, I actually mean dollars and euros. It's 10 a.m. Do you know where your money is? Hit the click, Tracy. This is just in the financial industry, and here are a series of software disasters that made the headlines, and you can see, if you can read what's highlighted in the little red circles there, these things are going in the hundreds of millions of dollars or euros. And so it is, some of these hit 9 digits. The one that really caught everyone's attention was Knight Capital, and you can see that one there. It's listed at 389 million. Actually, by the time it was all sorted out, it was around $440 million, and they were out of business. They went bankrupt. It was a bad update that somehow accessed some what they thought was dead code, and that contained a lot of out-of-date trading algorithms, which suddenly made $440 million worth of bad trades in 30 minutes. So they were bankrupt. So we're seeing more and more of these kinds of things. You can think in other industries, the famous Equifax breach that just, you know, millions of credit cards were stolen, and the cost to them was just astronomical. Next click. So the question is, are your assets safe if Wall Street's in session with problems like this in banking and financial services? And we've seen this over and over again. Let's go to the next slide. It's across all industries. I mean, I just showed you some in the financial services, but we've had outages in the airlines. Delta had one that was over $110 million worth of outages because they couldn't get tickets to their passengers, and they had planes sitting empty for over a day. And so we see this over and over again, the famous Target breach that cost the CIO her job, and 2 weeks later it cost the CEO his job. So these things can have ramifications, not just in terms of cost, but also in terms of executive careers. And so when you look at who's affected by this, it's not just the CIO. When you have these 9-digit glitches, it's the board of directors, it's the senior executive team, it's the VPs of the business sectors that were affected, the corporate auditors. Why wasn't this caught? Why didn't you assess the risk that these applications were having on the business? And these folks are accountable for governance and risk management and all the activities that really ought to be involved in trying to protect the organization from these big glitches. And when you go into life critical and safety critical systems, and Matthias will talk more about that in a bit, you know, the cost can get even higher. The recent Boeing problem with the MAX 8 is disastrous. I mean, they're going into the billions of dollars with the problem they had there. So these systems can really affect corporate profits, corporate existence in some cases. Certainly it can affect the careers of senior executives. So the question is, next trick, Lacey, what do we want to do if I'm an executive, to provide evidence that I'm doing my job. I'm trying to exercise governance over the risk of these applications to the business, over their risk to the public, if life critical or property critical system, and what actions am I taking as a CIO or a CEO to try to protect the business. And that's where certification comes in. Is there some way I can certify the software that will protect me from some of these disastrous occurrences? Because we're seeing these, you know, it used to be weekly, now sometimes it's getting to be almost daily, where we have major outages, major security breaches, major problems coming from problems in the software. So let me turn it over now to Matthias, who will talk more about these problems in actual safety critical situations.
Okay, thank you very much, Bill, and also welcome everybody to this webinar. I will be focused on topic software certification for functional safety as well as cybersecurity. And let's go to the next slide. Okay, here we go. And these are the topics I would like to cover, just giving a short introduction of functional safety versus cybersecurity. Also talking a little bit about the different classes of software you can obviously have, or you have tools, you have embedded firmware. Then I would like to show you some just high-level examples, what kinds of techniques and measures you can pick and choose for certain levels of risk reductions. We can talk a little bit about the challenges for AI if you would like to use this in a safety context. This is definitely a question that comes up much more often this year compared to the last years. And then my last slide will just cover or give you some ideas regarding the level of independencies and probably answers questions like, when do you have really to reach out to an independent organization and when is the certification needed? But generally speaking, just as an overview, and Bill already summarized this from a financial point of view, what went wrong in the past. The idea with the software certification is that you can perform an independent assessment related to different features of your software. That could be reliability, maintainability, functional safety, as well as cybersecurity are subjects we are focused on, because if something goes wrong, let's assume with your medical devices or with your machinery, or you have critical infrastructure, then it's very likely that someone's going to be injured, or you may or may not pollute your environment, and also you could maybe lose your assets. So that needs to be avoided. And of course, as a software engineer or as a software designer, you have to anticipate that you always have different use cases, different users are exposed to your product. And maybe just one feedback here from my end. Operators can get very creative in using your product, your software, in a different manner you never anticipated. So take this into consideration also. And again, the idea here is that your software, the safety and security should have priority. But what's important, maybe also for the manager to note here, that cybersecurity, functional safety, software certification, that will cost time. So it will also cost you some efforts and some money. And just as an overview, cybersecurity as well as functional safety, and there's nowadays, I guess one phrase I should mention is that functional safety is not possible without cybersecurity, because it seems that everything is going to be connected to a network nowadays. And in cybersecurity, you usually are in very active adversarial situations. That means someone really would like to break your product, would like to steal your secret to impact your availability. So that's usually what the cybersecurity focused on. So it's availability, integrity, as well as confidentiality. That could be different in IT security. So for IT security, you're probably more concerned about confidentiality. If you think about your medical records, it needs to stay confident. And usually questions we are asking is what kinds of security level is needed, and the standard, which is picked here as an IC standard 62443, is the complete series talking from or covering products and also complete enterprise architectures. And then on the other hand, you have functional safety. And here the main goal really is to avoid that someone is going injured or the environment is polluted because of a random or systematic failure of your design. And I guess the good news is software has only systematic failures. So by nature, you could claim that all systematic failures can be avoided, but reality nowadays is that software is just too complex, and you can't test it completely. So you have to find also techniques and measures to control systematic failures. And then on the other hand, of course, your software is running on some hardware. So you have to find also techniques and measures to control random failures because they can't be avoided. And typical questions here are what happened if an element fails, if your software fails, if your operating system fails? Are the failures detected before next demand has happened towards the safety function? Can we go forward and maybe use diverse software? But maybe going one step back here is talking about software. First of all, I guess it needs to be classified what kinds of software you would like to cover. Is it, are we talking about tools you have to use for your software design, for your software development, or maybe also for configuration? Or are we talking about software, the embedded software in your device, your operating system, application software, firmware? And general statement is that all software products that can have an impact to the functional safety behavior, to the cybersecurity behavior, needs to be considered. But just going forward a little bit with tools and then talking about what certification is needed for tools. So 61508 has just 3 simple classes, straightforward, depending on the impact to the functional safety behavior, to the executable code, for instance, and the class with the lowest impact are, for instance, text editors. And well, I guess it's obvious you probably don't have to have certification for text editors or for T1 class tools. But what about T2 as well as T3? T2 tools are usually tools you use for verification, for validation. It could be tools you're using for static code analysis, maybe tools you're using for figuring out how complex your software is. If this tool has a failure, it doesn't mean there's really a construct in your software that will lead to a functional safety critical issue or to a cybersecurity critical issue, but there is a potential for it. And on the last class would be like a T3. That's the classification on the 61508, and that means you have tools that are really impacting your executables. So it could be compilers, linkers. So that means your software can be 100% correct. Your code could be 100% correct, but still your compiler has a failure, has a systematic failure, and that leads to situations that the safety function is lost, for instance. So that needs to be considered, and this is just an overview in a more condensed form. 61508 has the same kind of requirements, but it's more written out. Nevertheless, for T2 and T3, you have almost the same requirements, like you have to have a product manual. Usually that's not a problem. Constraints are defined, that's also not a problem. But how you're going to perform an assessment. I mean, if you're in a situation that you have to perform an assessment for your static analysis tool, this can be done. I mean, you can seed errors, that's fine. But how you're going to assess your compilers, that becomes almost impossible for you. And here it's probably an advantage if the tools you are using are already certified. Okay, what else? I'm not going to go through the complete V model, but I just wanted to show you or give you an overview from a certification point of view, what you should be aware of. So for software certification, you can think about the technical techniques and measures you're considering during the design and development and testing, what kinds of formal, semi-formal methods you're going to use, how are requirements tracked, how is the code tested, white box test, black box test, functional tests, are code reviews performed? These are all the questions you usually have to answer during the software certification process. But on top of that, you still have to make sure that from a management point of view, you are up to speed. And that means you would also see questions towards what are your modification procedures? How is your bug reporting organized? How is this avoided that maybe different or similar bugs could be present in different products because you're using the same software baseline, for instance? Or how's the safety planning organized? Who's responsible for what? How you're ensuring that the people assigned to different tasks are qualified and competent. And the idea with the V model, just in a nutshell, is that everything is consistent. So everything that's specified is implemented, everything that's implemented is also tested, and by the end, you're performing an overall validation to your specification. Obvious flaw is if something is wrong in your software specification, your validation is not necessary to catch that, because you would perform a validation testing against an invalid specification. And just maybe two examples here for techniques and measures you can pick and choose during the design and development. The SIL stands for safety integrity level, and the levels are 1, 2, 3, 4 are related to the risk reduction. And just as an overview, SIL 1 would give you a risk reduction of 10, SIL 2 of 100, and SIL 3 of 1,000, and so on. So one requirement, obviously, for all different integrity levels is that you have to find a suitable programming language. So what does it mean? And just as a heads up, standard C is not a suitable programming language, but if you're using static code analysis, if you're defining a sub-C, as well as if you're performing code coverage, then standard C could be used. But what you also see here is, again, certified tools and translator is highly recommended. That's what HR stands for SIL 2, SIL 3, and SIL 4. So again, that points you back that if you have to design software in a functional safety or cybersecurity domain, then please go back to your manufacturers and ask them if the tools are already certified. Otherwise, it's probably a burden at your end. And also maybe just another example for the design and development. I'm just picking this one module approach. And what does it mean? There are different techniques and measures you will have to use. And one would be like complexity control. And it doesn't really mean that low complex modules are always safe and high complex modules are always dangerous. That's not what it means. But it means you have to control the complexity. And think about it this way. If the modules are getting too complex, that's horrible to test. And maybe at some point you really can test it completely. And also it's very difficult to maintain later on. So that also needs to be limited. But the good news is we have tools for that, and that shouldn't be a problem. Okay, then I would just go forward and maybe talk a little bit about the challenges for AI. That's what we've seen lately is maybe just as a summary here. The techniques and measures I just showed you, they are perfectly fine to avoid systematic faults for software which is based on certain rules, your standard software. However, those techniques and measures have no real advantage for data-driven algorithms used in an AI environment. So probably in an AI environment, you have to ask much more questions like, since your training is based on data, what's the quality of the data? And you could ask similar questions related to the coverage you asked before for your code. Here you could maybe ask questions like, what is the neuron coverage? What is your activation coverage? So you probably have to use different techniques and measures. And please consider also the frameworks which are available nowadays, like TensorFlow or PyTorch. They've been never ever designed so they can be used as a tool or as a framework towards functional safety or cybersecurity. And also keep in mind that those frameworks, they're constantly updated. You always have new optimizers, new loss functions, but it would be your task then to verify and to validate those functions. And maybe just as an overview, what is the current status of the relevant standards? And let's see, I have a couple of standards here. The ISO-TR 4804, this NXB, is probably, as far as I'm concerned, the most mature standard you can pick and choose right now if you would like to use your AI also in a safety domain. But generally speaking, there's also just a cut and paste here from 61548. AI is currently not recommended for any any cell, for cell 2, for cell 3, as well as cell 4. All right, so the standards are not mature enough, put it this way, to go forward with the certification if the AI is going to be used in safety critical tasks. I mean, you're already using AI in the medical world, you're already using it in financial, think about the fraud detection, or in IT, think about your spam mail, for instance. So that's already working, but again, not in a safety context where people can get injured or even worse. And the last slide from my end is just giving you some ideas, level of independencies, how is this related? When do you need to go to an independent person, department, or organization? And this is really related pretty much to what level of risk reduction is needed. And you will see that for the 3, for instance, it's preferred that you go to an independent organization like TÜV, for instance. Okay, I think that's all I have. I think questions will be answered after Bill's presentation. So I will hand over to Bill.
Yes, thank you. So what has CISQ done to help support certification, at least with measures, because that's our focus and the charter for what we do? Go ahead, Tracy. So we create measurement standards that are supported by the object management group, and some of them get then submitted to ISO. The 2 areas to date that we've produced standards in are measures of size, especially around function points, IFPUG function points, and measures of the quality of the software itself. And our automated function point standard is now an ISO standard, 19515. We have specifications for automating the measurement of 4 quality characteristics: reliability, security, maintainability, and performance efficiency. Those are 4 of the 8 that are in the ISO 25000 series standard I'll show you in a bit. We've combined those into one standard called Automated Source Code Quality Measures that has been submitted to ISO. We hear that it's going quite well, but it hasn't been formally approved for publication yet, but it's going through that process. We also now have just submitted to OMG a standard for data protection, because that's critical when you're trying to certify yourself against GDPR in Europe, or CCA in California, or CMMC if you're in the defense world. Those are standards that require protection of confidential data. So let's go to the next slide. This is how we create the CISQ measures. These are measures of based on detecting weaknesses in the software that would affect security or reliability or performance efficiency or what have you. So we look for severe known flaws in the code. This is done through static analysis. There's a number of tools that have implemented the CISQ weaknesses. And you can see the number of weaknesses. The number in parentheses is actually the child weaknesses of the primary weaknesses. In essence, there's the primary weakness would be buffer overflow and security, but there's like 12 different ways that can be instantiated, each one of which is a separate weakness. So that's the total number of weaknesses. Some weaknesses are actually appear in 2 different measures. There's a number of weaknesses, like buffer overflow, for instance, that's in security as well as reliability. But these are severe weaknesses. There's other weaknesses that could affect things like maintainability or performance efficiency, but they're not severe. And they're things you would just keep deferring and deferring and deferring, and those weaknesses are not included. If it's not something you need to fix now in the immediate future, then it's not included in these weaknesses. So Tracy, hit the next. These are examples of some of these weaknesses. So for instance, in security, you've got what have historically been the top 2 ways that hackers break into systems: SQL injection and cross-site scripting, and in many cases buffer overflows. In maintainability, you've got excessive coupling that makes the software extremely complex, or dead code, or hard-coded literal. So these are things that can cause severe problems for the code. Expensive operations in loops. If it's a loop that's exercised a great deal, that's going to slow down the system tremendously. So these are problems that need to be fixed. And what we do is we detect these in the code through static analysis. We count the number of weaknesses that appear, the number of instances of these weaknesses, and that's the base measure. And then you can derive a measure of density by dividing the number by the total lines of code, or the number of function points, or whatever your favorite size measure, to get a sense of what's the density of weaknesses in the code. And that'll tell you, whether you have high quality code or you have something that's in very poor shape. Next click, Tracy. Each one of these weaknesses, this was built by a panel of experts from a bunch of different companies, a lot of companies across a number of different industry segments, telecommunications and financial services and aerospace and a number of other areas. And these all exist now in the common weakness enumeration repository. Some of you may know of that. That is the repository of all the known weaknesses that hackers exploit to break into systems. So traditionally, it's been a repository of security weaknesses, and they each get a number, a CWE number. They've expanded that to cover more areas than just security. So now all CISQ weaknesses are included in the Common Weakness Enumeration Repository, which is a standard through the ITA, which is recognized by the United Nations. So we're trying to keep the CISQ measures as close to standards and involved in international standards as we possibly can. Next slide, Tracy. We tie these very closely to the 25010 software product quality model. That's an ISO standard. It's in the 25,000 series, and it lists 8 different software quality characteristics. And you can see the ones that are represented in light blue are the ones that CISQ has developed measures for. The ISO has a standard that deals with how to measure Z. Click the next one, Tracy. It's ISO 25023, which lists these measures, but it doesn't have automatable source code measures. It doesn't measure weaknesses at the source code level. It really just measures the behavior of the software. So reliability would be measured by the availability of the software, not by poor error handling or other things that could cause crashes in the software. So the CISQ measures supplement this with actual measures of the product itself, of the code and the architecture of the system. So we cover this, we supplement the ISO measures, we stay very close to the definitions of these quality characteristics in ISO. And by the way, if you listen closely to Matthias, you'll notice there's one quality characteristic that's not on this list that ought to be there, and it's safety. And we're now in the middle of revising the 25010 software quality model, and we've just gotten them to add safety to this list. I'm the American lead of the American delegation to the international delegation that's building this standard, and several of the delegations were very strong in their belief we had to add safety in here because that's a critical software quality characteristic. So you'll see that in the future. But of the current quality characteristics, these are the ones, the 4 we cover with the CISQ measures. Next slide. Now you could use these as one form of certification, as one to look at the product itself. There's looking at the process by which the software is developed and by which it's tested and by which it's put into operation, and certifying that that's a high quality process. But there's also looking at the product itself to make sure it doesn't have certain flaws that we know can cause outages or security breaches or other kinds of of problems. And so CISQ can be used, these measures can be used as part of an overall certification program. CISQ itself is not going to do certifications. What we do is endorse the static analysis technologies of vendors as conforming to the CISQ standard. In essence, they are able to detect the CISQ weaknesses and compute the CISQ measures. And so we would endorse a technology as being CISQ conformant, and then that could be used in the certification process. Next click. The technology vendor might do the certification, or a service provider, for instance, a system integrator, or a testing company, an independent testing company, might do a certification using one of those vendor products, using a CISQ conformant process for doing the code certification. So that's how this might be created. And then next click, Tracy. They would provide a certificate that says here is the quality of the software on this release of this version of the software at this point in time. So here's the problem. A piece of certification on a piece of software is valid until you make the first patch. And once you start making changes to it, you can create new weaknesses that weren't there before. You can violate rules of good architecture and coding practice. There's all kinds of things that could happen that would make any claim about the software to now be invalid. And so one of the real values of this kind of certification is for the organization, for executive management, for IT management or engineering management, to show that they are doing their due diligence to try to ensure that this is high quality software and that it meets the critical thresholds for what's considered acceptable software in that particular domain, whether it's safety critical, whether it's confidential critical, operationally critical, or whatever, that there is a risk threshold and that we are doing our best governance to ensure that we achieve that threshold and that we try to sustain it. And here's evidence of it. Mostly now there is a new way of in the security world for claiming that you have secure software, and it basically has you build an evidence-based case that you make claims about the level of security in your software and that you provide evidence that argues those claims are true, or at least that they're valid. And that evidence would be involved with testing, penetration testing, static analysis, other kinds of dynamic testing, and what have you, that and the process you use for building it, the secure evaluations you made of it, and what have you. So this is a part of the evidence. This is not the only evidence, but would be part of the evidence to claim that I have software that meets the threshold for risk in the domain in which this software is being applied. So as I said, CISQ does not do the certifications, but we provide measures that can be used by technology vendors and their service providers for at least providing evidence on the software that can be used towards certifying that at this point in time it met the following threshold. And you can do that using Six Sigma measures or density measures or whatever measures seem most appropriate. We have a tech report on the website, which you can access once you become a member, that describes our approach to conformance. We've updated the CISQ measures, so I have to update that conformance assessment method, some of the information that's in it. But this is one way to go about at least one aspect of certifying the software, at least against the severe weaknesses that can damage the architecture or coding that's in the software. Next slide, Tracy. basically what we're asking in the long run is, can I trust this software? Is this going to put me at danger? Is it going to put my business at risk? Is this trustworthy? Is this a trustworthy system? And how do I know it's a trustworthy system? What evidence do you have? CISQ developed a trustworthy systems manifesto saying, look, there's a number of things that executives should be demanding of their organizations in order to ensure that they meet the risk threshold for the domain in which their software is going to operate, which means they need to have engineering discipline, both in the process for building the product and the product itself, that there's good engineering practices in the product, that we have quality assurance sufficient to demonstrate we achieve the risk tolerance thresholds, and those thresholds will differ depending on whether we're in a safety critical system, a life critical system, or a personnel system or something else. But if a retail system where I've got lots of customers that I don't want to lose, and if my software keeps failing, they're going to leave. So what's my risk tolerance for problems in the software to know that it's going to be operational during my peak retail hours? And more and more our software is built from multiple components, some of which come from open source. And what are the properties of those open source components? Well, we didn't build them, and we don't know all of the people who have had access to it during its development while it's sitting out there in open space. And I would like to know, does it have known vulnerabilities that need to be patched? Are there licenses that I need to worry about, or intellectual property aspects that could put me at some legal risk if I use it or don't use it properly, or can I make changes to it? So there's, who's had possession of this software prior to me getting hold of it. So it's sort of a software bill of materials. I need to know that because that could put me at risk for using some of these open source components. And how am I going to protect the system and the data that's in the system? We had an expert from Homeland Security a few years ago come to one of our cyber resilience conferences, and on a panel say, look, the only safe assumption you can make is that the bad guys are already inside your system. They've already penetrated your system. So the question you have to ask is, how am I protecting my data? And can I detect that they're there and find a way to get them out? But the first thing I've got to make sure is they're in there, but they can't get to the data. I can protect the confidentiality or whatever other kinds of protections I need for the data that's in my system. And finally, is this thing going to be resilient and safe in operation? Is it going to meet the standards for software in that domain? If it's high-speed trading on the stock market, if it's an avionics system that's flying airplanes, or an automated system for driving a vehicle, or medical devices, or whatever, telecommunication software that runs our networks, what are the resilience requirements, what creates safe operations, and what kind of risk am I allowed in that environment? Is it near zero, or is it more lax than that? And have I done the things I have to do to make sure I reach those safety tolerance levels? And can I certify with some evidence that I've done the things I need to do to achieve the risk tolerance I need to achieve for the software and the environment that the software is going to operate in? Software is never going to be perfect. Even the best software ever built, which was the avionics system for the space shuttle, wasn't perfect, but it was about as close as humans can get. The problems they had were always hardware. The software was really beautifully built because of the process, because of the way they tested it, because the claims they had to make to NASA about its operation. But we need to know the software is trustworthy, and certification is one step in that direction. And part of certification is having the evidence that through static analysis, through process assessment, through a number of other things, that we have done our due diligence and exercised governance over the level of risk that software presents in the environment it's going to be placed. So next slide, Tracy. This is the CISQ website. I encourage you to go there, and there's a little member button you can push if you want to become a member, and it will ask you a few questions, and then Tracy will send you a password, and you're in. It's free because we're sponsored by several companies. And there's the standards that we've developed. There's blogs about various aspects of structural quality of software. There's going to be a report. We're about to release our next report in January of the cost of software quality in the U.S. The numbers are staggering. It'll be a fascinating read. And there's also all the presentations that have been made at our cyber resilience conference by some of the senior people in government and industry that are tasked with overseeing some of these critical issues. This, you can see that the companies that our members have come from, it's really the Fortune 2000. We're approaching 4,000 members now, and they're from a lot of the large companies globally. So we are really trying to be a global organization that serves a global purpose, as is the TIC Council as well. So these are two organizations doing everything we can to make software more secure, more reliable, more safe, more dependable and trustable. So next slide, Tracy. Thanks for attending, and we'll go to question and answers. Tracy, it's over to you.
Back to me. Awesome. Okay. We do have some questions. Here, first question is about asking if CISQ has a relationship with other software quality groups, like the Software Improvement Group.
Yeah, actually, the Software Improvement Group was one of our original sponsors, and they had several people very involved in helping us define the software quality measures. So they have been involved in some of the work that we've done in creating measurement. They were also very involved in help create the function point standard as well. So they have been involved in a lot of the work that CISQ has done very early on.
Mm-hmm. I know you talked quite a bit about MITRE common weakness enumeration and how the CISQ quality measures are built off of that, and then the relationship to ISO 25000.
Yeah, and you can see our partner list, and a lot of those organizations are tied into software security in one way or another, or software quality.
And the next question, we've started obtaining ISO 27000 certification for our SaaS asset offerings. ISO 27000 certification focuses on the information security management systems, setting policy, procedure, governance, and metrics. Can you talk about the relative importance to risk mitigation of this kind of certification versus technical certification of software?
Well, there's two aspects, right? There's the process by which you build it, and then there's the product that you built, and you need to look at both. And a lot of the certifications, I was led the development of the original capability maturity model, which was used to evaluate how good a software company was, but we looked at the process, not the product itself. And so I can have a great process, but if my people don't really understand the domain of the application, or they're new to software development, they can make mistakes. And so we do need to look at the product itself. They need to be complementary. We need an analysis of the process and an analysis of the product. So a lot of the ISO standards primarily look at process, and the 25000 series looks at the behavior of the software in operation. And so what CISQ has tried to do is supplement that with the ability to analyze the product for weaknesses that we know would affect some of these critical quality characteristics.
And then a question for both you, Bill, and Matthias, be like, how do you see the certification effort aligning with legal changes or challenges to terms of service agreements? In the U.S., we tend to be very litigious. So how do you see the certification effort aligning with legal changes or challenges to terms of service agreements?
Well, we've put some language on the CISQ website that can be used by acquisition managers, outsourcing managers, in their contracts to talk about some of these quality characteristics and how they'll evaluate it. And the question is, what's the level of quality you need to achieve? What's your risk threshold? How are you going to evaluate it? What do they need to achieve? What if they don't achieve it? Are there penalties, or do they have to take it back and rework it at their own cost? So you can use these certifications as part of acquisition, as part of the acceptance process for accepting software back into your organization. Now, when you go to court, right, one of the questions that's going to be asked is, were you at the state of the art or the state of the practice in developing software? I mean, did you take unnecessary risk because you were negligent, because you were lax in your practices, because you didn't evaluate adequately the software itself? And so certification is going to be evidence. If you build an evidence-based certification argument that looks at the certification of the process and the certification of the product, to say, look, we have done due diligence to the level that is professionally acceptable for the domain we're in, and that's, that'll differ based on life critical versus business critical software, for instance. But this is part of building the evidence you would need to defend yourself as having done the proper engineering development and the proper governance. Matthias, do you want to add to that?
No, I absolutely agree with you on that. So as long as nothing goes wrong, nobody cares. But as soon as as soon as something happens, then you have to prove that you did what was state of the art. And of course, you can use your own approaches. That's perfectly fine. But then you would have to show that your own approaches are at least as good as what's covered by current standards. And this could be a special task for you, put it this way. What else we've seen in the past, starting 2018 for safety of machinery, that for instance, software, if software is used to perform safety functions, then the software needs to be listed and labeled. And this terminology, listed and labeled, is very specific here in the US. And that in the end means it needs to be listed and labeled by an entity that is accepted from the authority having jurisdiction. So that could be something you have to be aware of when you are designing software and when you are signing service agreements.
Thank you both. Another question just came in. Having a largely automated evaluation process is great, yet there's a limit to what tools can verify. Do you envision different assurance levels of the certification where higher assurance levels would involve manual code review as part of the evaluation? That was maybe for you, Bill.
Yeah, that certainly can be. Yeah, I mean, we can pretty much look at the code level and with automated tools. Once you start looking at architecture, there are tools that can do that, but they don't detect every architecture level problem. And so I think, yeah, at that point, having some kind of a disciplined review process could be a part of an overall. I mean, it's part of the evidence. It's part of the evidence that we are doing our due diligence, and that can be part of your certification argument, in addition to the evidence you get out of the automated tools. But you'd want it, some really good companies have built checklists saying these are problems we have detected in the past, and we know that these are things we should look for, and either with an automated tool or with a code review. If the tool can't do it, these are things that we have to consider in a code review or an architecture review. But look for tools, because that can cover a great deal of the space. These systems are so big now that the concept of trying to review everything with manual reviews is a nightmare. They're so incredibly complex, and so you really do need technology to supplement anything that humans are expected to do. And there are tools out there in the market. I won't kind of tell you which ones they are, but I would encourage you to go look at certainly our sponsors, but also others, to see which tools can do the higher level, more architecture level analysis.
And maybe from my point of view to add is, of course, different standards have different assurance levels, like 61508 has safety integrity levels related to the risk reductions. The cybersecurity standards have different security levels related to the attacks you will have to deal with. But there are different requirements for this assurance levels, and Bill mentioned the tools. Yes, that's absolutely right. So just giving you an idea, for SIL 2, that gives you a risk reduction of 100. It would be sufficient if your tool can, for instance, check that your tests are sufficient to execute each line. That's perfectly fine. For the 3, that would be a next higher assurance level, your tool needs to show that your tests are capable of covering each branch in your software. Like an if usually has a false as well as a true branch, so that needs to be covered. So yes, different assurance levels are available on a certificate, but the certificate will just be, the certificate in the end.
All right, and then maybe back to you here, Matthias. This might be our final question, unless some others come in. But could you talk a little bit more about the role of AI in the future of software certification?
Yes, sure. I mean, this is something that really comes up more and more often in our day-to-day business. So companies are, as you know, I mean, they are building autonomous vehicles, driving on public road or driving on constraints, maybe on fields or on certain construction sites. So that's definitely something we see. And there's one standard, maybe I didn't present in the presentation, so I just copy it real quick here to the chat. It will be in addition to 61508. And there's a subcommittee SC42 working on questions, I hope you can see that, related to AI, if it's used to perform safety functions. And I guess the general problem we have to face is that with the current standards, I mean, they've been designed for rule-based algorithms. So all the techniques we talked about, like code coverage, static analysis, it still needs to be done. There's no question about it. But it's like an initial condition. It has no real value for data-driven algorithms because the workflow is just different. Like first you have to understand what is the objective, how does your framework, you have to pick a framework, you have to understand the source of your data, you have to think about the quality of your data, you have to train the model, you have to test the model, you have to validate the model, you have to make sure that training sets and testing sets are using different samples, so this should be disjoint. So this is just lots of different requirements which are not covered by the current standards, and the standards which are in design, they are not just mature enough. And this one technical requirement I just mentioned here in the chat, that's going forward, but I would assume for at least another 12, probably more like 24 months, we have to look into the future before we will see final standards that can be used to qualify systems using AIs in a safety context, like a functional safety, for instance.
Mm-hmm. Thank you. Okay. Well, this was a nice presentation. Thank you, Dr. Bill Curtis and Matthias, for presenting today, and Karen for co-hosting with us. Again, we recorded the talk today and have the slides, so we'll send those out to you so you have a copy of both. And we look forward to seeing you again at a future webinar. If you have any questions or want to follow up, feel free. Our contact information is here on this final slide. And everyone have a great rest of the day. Thank you.
Thank you. Bye.
Thank you. Bye-bye.